today's session, we will be talking about how to reliable energy model with Solargis data and also its integration with Pvsyst. So let me introduce ourselves. I'm Marta from customer support, and I will be presenting this webinar. And here with me, I have my two colleagues, Mamadou from customer success, who will be presenting this webinar, explaining you everything, and also Harsh from our product manager, who will be here to support more technical aspects of your questions. So if you're ready, we can start. So Mamadou, please.
Yes. Thank you very much, Marta, for the nice introduction. Hello, everyone, and welcome to today's webinar. Today, webinar will present the different points which we presented here. So we would like to first show you how you can access different Solargis data sets. Then we will explain you the differences between the type of data. So we'll explain what differentiate the monthly averages versus TMIs, which are typical meteorological year data versus time series. And then we will also run few case scenario simulations where we import Solargis data into Pvsyst and then present also our findings. Then at the end, there will be a quick reminder on how you can reach out to us in case you need support or simply access our documentation resources. There will be a Q&A session as just mentioned by my colleague Martha. So let's go ahead now and see how we can access Solargis different data sets. So as you know, we currently have two websites, so solargis.info and apps.solargis.com. The main reason is that we've been working on the transition to the next generation of apps that are prospect, evaluate, monitor, and forecast. And these apps will eventually replace the current apps which we have in solargis.info. So that's the reason why we have these two websites. However, it's very simple for you because we just recommend you as a first step to create an account on solargis.info, because then you can use the same credentials and access apps.solargis.com. Now, we will also show you, after you do that, you can pretty much choose your data subscription plan that you would like to purchase. And as a step 3, you can also always download CLIM data. You can access CLIM data, to download time series and TMI data, or simply download monthly averages via apps.solargis.com into the prospect app. So we will explain a bit later more details. In this slide here, we would like to introduce you the differences between the monthly averages against TMIs and time series. So as you can see, when we talk about monthly averages, we pretty much talk about using this data for due diligence, for pre-feasibility studies in order to find out the best location to install the PV system. So in case of prospect, it allows you to access data, monthly data and yearly averages from 1994, depending on the region, up to 2020. So these are 12 months data points which are used. Time series and typical meteorological year data are used. In the case of time series, they are used for the project development, and in some cases, they can also be used in operational performance monitoring. However, TMIs are typically used in the project development. So you can also have in this slide the different number of parameters, number of data points per parameters, as you can see, and also the historical data which is available from 1994, of course, up to last year. And now to explain a little bit more and show you how pretty much this type of data looks like. In this slide, we have presented the monthly averages data. So as you can see, these are monthly averages from January up to December, so long-term monthly values. And you can see in some cases, for example, in case of the solar resources such as GHI, the global horizontal irrigation, we do a sum in order to have the yearly value. But in some parameters such as the temperature or the albedo, we simply calculate the average value from the monthly values. Okay. When it comes to time series, Here we are showing a geographical representative of time series data from 1996 up to 2020. So these parameters which are shown here are the GHI, the global horizontal irradiation, direct normal irradiation, and the diffuse irradiation. And then in this slide here, we have the typical meteorological year data, which we refer to TMI. Again, here we are showing a plot of the TMI data when it comes to GHI, DNI, and also the diffuse irradiation. So now what we would like to do is we would like to go ahead and show you guys how you can order this data. So first of all, we'll need to, of course, create an account in Solargis.info, as I mentioned earlier. And then when you purchase a subscription from us, you'll have the possibility to see exactly what I'm seeing here. Of course, this will be referred to the subscription that you have with the number of credits that you have. So let's go ahead and try to order film data, time series, and TMIs professional plan. I'm going to go ahead and click on contract. Since you already have a contract, you just click on it, and we can order some data somewhere from France. So of course, what you can also do is to simply type in here the coordinates of the sites you want to download data. So I'm going to select a random site, and then as soon as selected, I will go to continue. And then here you can also choose what type of data delivery you would like to have. If you would like to have, we can go ahead and try to import to download TMP50 plus TMP90, 15 minutes time series. And we can also add the global tilt irradiation or the plane array, commonly known as the plane array. So here we can choose configuration of one axis tracker, horizontal north-south, and we can also adjust the relative row spacing. Okay, you could also choose the rotation limits of your tracker. So in this case, from 90 to 90. And once you set this parameter, you click confirm, and then yeah, you can then add to cart. So, and then all from here on, it will be very simple, because all what you will need to do is to follow the steps which will be indicated for you. When I click next to summary, you can also choose the PO number that you would like to input, read and accept our terms and conditions, then send the order. And then what will typically happen is that we will send you an email confirmation once we are ready to calculate your order. Then in the email, we will send you a link, and the link, when you open the link, it will show you exactly the information that I'm showing now. You'll have all the data here which you can download. So for the time series, you will have a CSV file, and for the TMIs, you'll have both of them CSV files. Sorry, however, in the time series, it will be a zip file which you can also download. Now, to just show you quickly how the data looks like. So when you open the time series, the TMI, sorry, you will see that the data will turn to look like this. You'll see that it's a 1 year data with the different parameters mentioned in there. And for the time series, it will be again the same. So you will have all the parameters which are presented, the solar and meteor data. And then when you scroll down, you can see all the parameters of the time series. Okay, now that we have shown you how you can download this data, let's go ahead and continue with the presentation. Now let's talk about typical meteorological year data. So as you know, typical meteorological year data are widely used for project development. So we wanted to explain you pretty much how do we calculate our TMIs. Solargis TMI data are calculated using time series data. And what we do is that we use the most representative months from the time series and concatenate them into 1 year data, which we call TMI. So if you look at this picture here, you can see that we calculated a TMI data using monthly data from available time series. For example, we use the January from year 2016 2004, sorry, and we use the February from year 2003. Solargis TMI data are calculated in a very precise way. We use two main characteristics. The first characteristic is that we minimize the statistical difference between the characteristics of the time series and the TMI data. And then the second criteria is that we maximize the similarity between the monthly cumulative distribution functions of the TMIs and the time series. The reason why we do that is that this will help to make sure that the occurrence between the typical hourly values are well represented in the months, right? And so like that, we are able to have the most precise TMI data extracted from the time series. And to also add one more point is that it is important to mention that the consistency of our TMI calculation, because when we do calculate the TMI, we use the equal weightage between the GHI and DNI parameter and also the temperature. However, this is not done in the same way for the TMIs which are provided out there, which mainly focus on giving the all weightage to the GHI parameter, and therefore parameters such as the DNI and the temperature are ignored, while these are parameters that should be taken into consideration for solar applications. Okay. Okay. And now we can go ahead and start to talk a little more about simulations, the site we decided to choose, and also the configuration. So as you can see, we decided to simulate and extract data from a site in Spain. The configuration parameters are presented in here, so you can go ahead and see the different values and setups which we have chosen. So when it comes to, now I would like to show you a bit prospect, but meantime, my colleague Marta can probably jump in and bring some information.
Yes, like in this webinar we won't enter in detail into prospect, but just to inform you, we did our previous webinar, like showing you all the features that the app has, how to make a project. So if you want to know all the details about prospect, you can check our previous webinar. Which you will receive the link to check it in the documentation that we will sending to you after the webinar. So in case you're interested, you can just check there.
Okay, perfect. So now when we go to prospect, so this is basically the solar and meteor data that I was showing you previously. As you can see, the values are clearly mentioned here in this table with all the parameters. Now here, I'm just interested to go ahead and download the data file. So I will go to this section and just click on download. Then this is going to be the CSV file, which you will therefore use to if you would like to import it into Pvsyst for more advanced simulation. Now, this was just to show you how you can get the monthly average data from prospect. So in this slide now, I would like to present you the different simulations which we have done using Pvsyst and Solargis. So we considered 4 case scenarios. Our first case scenario, which is the one which we used as a reference, was basically simulating time series data into Pvsyst. So we imported 27 years of data into Pvsyst and run the simulation. On the scenario 1 is the simulation which we have run in Prospect app. So this is basically what I have showed you in the previous slide. And in the scenario 2, we imported the monthly data which we extracted from Prospect into Pvsyst and run the simulation. And in the scenario 4, we simply simulated TMP50 data into Pvsyst. Okay. Now, we talked about Pvsyst, so we would like to quickly show you how you can work with Pvsyst when you would like to do more simulations. And here again, I'm going to pass the ball to my colleague Marta for some quick insights.
Yes, just quick information that in our web, in the documentation part, you can find an article about the integration with Pvsyst and Solargis data. So now we're gonna run quickly the simulation, but in case you're interested, you can check step by step how to do it. So again, this link will be provided at the end of of the presentation, and you can have access to it, or directly in our web. If you go to documentation, you can just check it. So you can continue, Mamadou.
Okay, perfect. Thanks, Martha. So that said, in PVSys, you need to first create the meteor file. So you simply have to go to database, and then you have to go to extract your file. So in this case, it's going to be TMI, P50. Yes, perfect. And then I'm gonna just go ahead and, sorry, before that, make sure also that you're using the representative data source here. So the TMI are hourly data, that's why we use the hourly here. And then I'm gonna go ahead and simply extract, load in my files. So it's a bit, okay. So in the raw data here, I simply just have my TMI file, which I imported. And you will see it will just, yes, perfect. It will take some time. And then after doing that, you can import the file here. So I'm going to go ahead and overwrite it. Okay, so my meteor file was now created, right? So I can also open it quickly to see about the quality. So you can see that everything seems to be okay with the file. So I will close. And then I'm going to go ahead and save my site. So this is basically my site, my zip file. And you'll just need to wait a bit to make sure that the zip file was perfectly created. Perfect. So both of them have turned green. Now we can close this. Now that we created our meteor file, we should be able to go ahead and import it for simulation. If we create simulate grid connected system, we need to first make sure that we save the project. So you can simply call it webinar test example and save it somewhere. Okay. And then here, make sure also to use the zip file which we just created. So that should be the TMI, the one with the TMI. So normally you can also choose the namings here, right, to make sure that you are using the right file. And of course, you will need to also do some setups in the parameters here of the system. This is mostly depending on your preparations, what type of system you would like to simulate and how you would like to adjust all these parameters. Once these values are simulated, you can go ahead and run the simulation. And then, so that's how we imported the data, Solargis data into PVSys for advanced simulation. Yeah. So we have run all these simulations scenarios, and in this slide here we are showing you the results which we were able to compare. So as you can see, our findings was that when we import monthly averages into PVSys for simulation or advanced simulation, we were not able to really find a big difference when it comes to the performance ratio. As you can see, the deviation observed in the yield is pretty much, yeah, it's pretty much not considerable. And also the performance, yeah, as I was saying, the yield is pretty much similar, sorry, between the value which we extracted from prospect and the value which we get from simulating long-term monthly averages into PVSys. But when we simulate time series or TMI, we see that there are differences. Differences start to rise. The next step was to have more understanding on how we can pretty much explain these differences. And then we went ahead and did the correlation. What we did was that we correlated the losses of diagram from prospect app with the losses of diagram which we obtained from PVSys simulation. So as you can see, all these losses parameters simulates quite well. So both they correlate quite well. However, we noticed some differences. For example, the first difference would be about the clipping losses. We see that it was there were some differences on the clipping losses when it comes to PVSys compared to the prospect. And this is simply because in PVSys we set a DC-AC ratio of 1.4. However, in case of prospect, the DC-AC ratio used as default is 1.2. So that's one difference. And the second difference is the power tolerance of the PV model. In Prospect, we do not take into consideration these parameters. However, in PVSys, you can see that the corresponding value about the module quality loss is actually given in here. And one other difference is also when we talk about the losses which occur due to interrow shading. In Prospect, we take all these losses and calculate them as electric and show them as electrical losses. However, in PVSys, the losses corresponding to the interrow shading is split into two parts, into the optical losses and the electrical losses. And then the last difference or latest point here would be that when we talk about the degradation of the PV modules, in case of Prospect, we consider the degradation from year 0. So that's why we need to take into consideration the annual degradation from year 1 onward in order to be able to correlate it with PVSys. As in PVSys, the degradation occurs from year 1. So these were the main differences which we observed from this correlation. And now to summarize and conclude, based on these simulations which you have run with the different case scenarios, we were able to see that when you run pre-feasibility studies, Solargis Prospect app is 100% reliable for such assessment, and it doesn't make you much at point to import long-term monthly values into PVSys. However, when you work about project development where you need to do more advanced engineering and detailed engineering, sorry for repeating myself, and also optimizations, or in some cases you will also need to do financial calculations, which we know can also help to reduce the cost and also minimize the project risk, then it's become more interesting to use time series and TMIs. Simply because they provide high accuracy, which is the best representative of all solar and meteor parameters. And also you'll have the possibility for site adaptation, which can be used to correlate with measured data as well. And time series provide more details and accuracy when it comes to year-to-year variability, and also extreme values, possibility of calculation when we talk about TMP90, for example. And then, yes, so these were also the second concluding point, and the third one is pretty much what I explained in the first. But yes, it's when you work in due diligence, we do not recommend to use long-term monthly averages because this can lead into suboptimal technical design and can later lead to higher uncertainty when it comes to the energy yield that your PV system will generate. So here we have summarized the resources which you can access. They are available in our website. The integration with PVSys is also explained there in detail and can help you. You can follow our release notes to be more updated into our latest features, updates, and developments, or simply follow our blogs to learn more and more about our development plans. We do also have a product board, so this is something that I strongly recommend all of you to go and have a look, because you can see it to submit features, ideas, or simply vote for your favorite feature. And then Prospect app webinar record is also available in Prospect in case you or your colleagues or new users would like to learn how to reach out to us.
Okay, thank you so much, Mado, for all the presentations. And okay, so now we can start the Q&A session. We will go through all the questions, try to answer them, and so we can start then. So here we have again our product manager, Harsh. So let's start. Our first question that we received is, well, I see some questions not related to the webinar, so maybe these ones you can ask via email, but let's try to answer. So first one, do you consider climate evolution, like solar brightening, dimming, temperature raise into the TMY methodology?
Yes. So I explained it during the presentation. So when we our TMIs is pretty much besides the two criteria which we use, the statistical criteria and maximize the cumulative distribution function between the time series and the TMI. Yes, we do use equal weightage between the GHI, the DNI, and the temperature to calculate the TMI. So this is something this is something which needs to be done, because we should not just be using focusing all the weightage into the GHI, because the DNI and the temperature parameters need to be also taken into consideration. So depending on the solar application, of course, that you're developing, so these parameters have an impact and should be taken into consideration. So yes, we do take them into consideration.
I'd just like to add that another question probably that the questioner had was whether climate change has any impact on the typical meteorological year data, because the typical year data is based on the data from last 20-25 years, and the question is whether the weather for the next 20-25 years will be the same as the last 20-25 years. So I would say that for temperature, this is kind of well documented, and we know that the temperatures might be, let's say, 1 degree or 2 degrees higher in a decade or so from now. So this is currently not considered. As regards radiation, this is very tricky to say, because for sure we can imagine that climate change might have some impact, but with the data that we have today, going back only last 25 years, it's very difficult to predict whether at a particular location the radiation is going to see an increasing trend or a decreasing trend. So this is currently an open research topic within our team, which we might hope to throw some light in the near future. But at the moment, we do not consider like climatic trends or how the solar radiation is changing over the last decades when we create the TMY file.
Okay, I hope the answer, you can understand the answer. Then we can go with the next question. So, is the GTI value mathematically derived from GHI and DNI? How do we calculate this GTI?
I can try to answer here quickly, but then of course Harsh can bring more clarification. So yes, into the model that we use, we basically use semi-empirical models, right? To just quickly summarize, our model is divided into three parts. The first one, we use the clear sky model to retrieve the solar irradiation falling on the ground, assuming the absence of clouds. And at the second step, what we do is that we use satellite data. So we have 5 geostationary meteorological satellite data, which allow us to cover pretty much the globe. And we use those data to calculate the attenuation impact of the clouds by measuring the cloud index. So then we couple these two, the clear sky in the cloud index, to retrieve all sky irradiance. So this allow us to retrieve the GHI and the DNI. And then yes, at the third step, we derivate the diffuse and the GTI from the GHI and DNI.
Yeah, and I would just add that we are using the Perez transposition model, which is like used in Pvsyst. However, there might be some differences in the exact implementation of the model, like the coefficients used and so on. So it may be possible that when you put Solargis, GHI, and diffuse data to Pvsyst, and you calculate the GTI in Pvsyst, you might get a result that might be, let's say, 0.5 to 1% different compared to the result that you get from Solargis. And I would say 2 main reasons for that difference would be like slightly different implementation of the Perez model, and also the other difference would be that we would typically run the calculations in a 15-minute time step, whereas in Pvsyst it's done on an hourly time step. So for fixed tilt, maybe not such a huge difference, but for tracking systems, you might see bigger differences, particularly in the early morning and the late afternoon hours.
Perfect. Thank you so much. Okay. Another question. What happens if we do not choose the type of panel array? There is default array. I normally have to simulate on different type of arrays.
I did not get fully the question. Can you please come again, Martha? Sorry.
Yes, basically, he's asking if we have to choose like any panel array by default. I guess this is referring maybe to prospect when you have to choose a PV configuration, because in time series you don't really have to choose any configuration. So you have different types. You can just choose fixed tilt, or you can have tracking with one axis or two axes. If you are referring to that, yes, you can choose that. Or in case you just want irradiation data, you don't have to choose any. I don't know if it's referring to this exactly. If not, you can just write.
Yes. Yeah. So if it's the yeah, so I would say also this depends, of course, on the type of configuration. Yeah, just like what you mentioned that you'd like to use. Of course, you know, like when you the configuration and the systems you'll use when you simulate ground mounting system, you know, won't be different than when you simulate an axis tracker. When you simulate a tracker, yeah, a system with one axis with tracker, for example, one axis tracker, where you need to set up information such as the if you'd like to enable the backtracking or so on, the tracking strategy in a way, right? So I'll say, yeah, pretty much depend on the yeah on the type
there is
of
no default configuration. You just need to specify what is a configuration in order to calculate the GTI.
Yes.
Okay. Next question. So for a more precise calculation of soiling and snow based losses, the hourly meteor parameters, precipitation and snow depth are needed. So when is Solargis implementing those two important parameters into the dataset in time series? So basically, snow depth and precipitation, if we can implement these two parameters in the time series.
So I just want to touch base a bit here now on the snow losses, and then Harsh can probably add more. So currently, we are, as a part of the Serendi project, we are working on the snow model, because what we are working on the snow model, which will pretty much be more accurate in a way than what we have on Prospect, because as you know, on Prospect, what we show is pretty much the monthly values of we show the monthly values of the snow. However, this should normally be it should be monthly characterized in a way of the specific days where the snow falls on the panels, because simply, yes, so the snow will be assigned to, will lead to the fact that the plant won't be operational. So now this new model will be able to more quantify the snow losses, but it will not be translated into losses, but it will be mostly assigned to unavailability of the plants assigned due to snow. So this this will have more understanding, more this will bring like more clarity on the impact of the snow on the energy yield. And I would just pass the ball to my colleague Harsh when it comes to implementing this on the time series, for example.
Yeah, so we know that it is requested future and it is on our roadmap. So we've been making some progress towards this. So today we already have the precipitation and snow depth data calculated in our database. And the reason why we were not already including it by default was because of the time it would take to deliver the data. So previously for time series data, the calculation time was 10 minutes. And if we had to read additional data parameters, it would increase the time. However, just last month, we have moved to a new data infrastructure. So those of you who are already today placing orders for the time series data might have noticed that the data delivery time has improved. So previously, each order was taking like 10-15 minutes, and you will now see that the orders will be processed within 3 to 5 minutes. So this process is now complete, and the next step is to also input the additional parameters. So you can expect it hopefully within a few months from now.
That's perfect. Okay, thank you so much. Again, can you remind about the spatial resolution of the parameters of the data?
Yes. So in Prospect, we use the spatial resolution used in Prospect is in the range of 90 meters up to 4 kilometers. However, there might be differences into the resolution when it comes to the solar maps that will be more accurate. That will be more accurate than the meteor maps. And in case of evaluate, the spatial resolution we use pretty much will be from, I would say, the time series spatial resolution is in the order of 250 meters. Right. Yeah.
Anyways, this information you can always check in the web. Maybe Hart, do you want to add something here?
No, that's it.
So just to know exact parameters in our web documentation, you can just check all this information. So we can continue. Okay. Why we should buy Solargis data if we have Pvsyst subscription? So basically, what is the difference between Pvsyst data and Solargis data?
Okay, that's a good question, and I see that Harsh wants to also say something. Yeah. So as you have seen in the simulation results which we presented, right? You see that there is pretty much no noticeable difference in the yield, in the energy yield, when you import long-term monthly average data into Pvsyst, right? Now, why you should buy Prospect data? Simply because if you choose to do that, yes, you should consider buying Prospect data, whether it is Solargis data, whether it is time series or monthly averages, because you want to use data which are accurate, right? So as you know, Pvsyst uses as a default meteor file Metronome data. And we have written a comparison report, which is available in our website as well, where we pretty much compare our data and our way of generating the data against the Metronome. So there are many aspects. Metronome pretty much uses synthetical values. So what Metronome does is that it's their way of calculating the data is mainly based on linear interpolation. However, in our case, our data are accurate. For example, in case of Prospect, we use sub-hourly data in order to generate the data, right? To end up with the long-term monthly averages. And also, we talk about the global coverage, the historical availability or disponibility, I would say. These are parameters that need to be taken into consideration. Yes, so I would say mostly the accuracy. Yeah. So Harsh, you can go ahead and add also more or explain in detail. Yeah.
Yeah, explained pretty well. I think if any doubts, you can just ask, but basically accuracy, of course. Then just to make it clear, there's one question, like, if you can try to explain again the difference between TMY, Prospect, and monthly time series data. You can quick explain differences.
Sure, we can explain that. So when we talk about monthly averages data, this is exactly what you get from Prospect. So this is based on data from 1994 up to 2020. We recently just updated our map layers in Prospect to cover last year as well. So what we do is that we generate long-term monthly average values from the available historical data. So Prospect, it pretty much is going to give you 12 data points, right? So which means you have access to 12 data points, and then you have the average yearly values, which is calculated from the monthly values. However, when you compare it to time series, for example, this is different because time series are data from 1994 up to last month, and the summarization and the summarization can be up to sub-hourly. So, which means we are talking about way more data points in case of the time series than in Pvsyst. And the one difference that will just that can be just like explained will be pretty much, it will help you, like you'll have more visibility, more understanding on the year-to-year variability as we explained earlier, and so on. Now, when we talk about TMIs are derivated from the time series. So TMIs means typical meteorological year. So this is basically a 1-year data which we calculate using time series. So we use the most representative months of the time series. I already explained previously about the method of generation. So prospect long-term monthly averages, time series, you have sub-hourly data for the last 27 years, and TMI is 1-year data calculated from time series.
Good. So for different phases of the project, you will need different kind of data. Okay, so then we have other question. Okay, here is asking about the default parameters in prospect, like how do we know the AC/DC ratio assumed, if it's crystalline modules efficiency, what about the default parameters in prospect? Can we change them?
So in prospect, we currently use a DC ratio, default value of 1.2 for the DC-AC ratio. So of course, there are some nuances that are involved in that, right? Yeah, so it's important to also take into consideration that when we the 1.2 was found to be an optimal value in order to avoid clipping losses. So that's why we're using that ratio. So it should be that ratio. So it should be optimum. However, we are also planning to have the possibility to adjust that value. And in the future, we should be able to have that, and then the user will be able to pretty much readjust the DC-AC ratio.
Okay, and yeah, the module by default is crystalline silicon, but we have to remind you that prospect is a tool for pre-feasibility study, so we don't enter in this kind of details because it's not for this phase of the project. So just for a general idea, like it gives pretty much accurate simulation. Okay, okay. What about the lower temperature for absolute voltage limit? Is it possible to change it? And what criteria we can base on?
So let me take this one. Yeah. Today we can provide you 2 data products. One is the prospect app and the other is the time series. So you want to know the lowest temperature for the string sizing for the absolute voltage limit. In the prospect app itself, you are not able to today do the string sizing itself. What you do is you enter the installed capacity, and by default in prospect app, basically we are running a simulation for a 1 megawatt predefined block. So if you set a capacity of say 5 megawatt, we simply run a simulation for a 1 megawatt predefined block, and we multiply the results by 5. Then in evaluate, you do get a time series of the temperature. So you have the hourly values, and you can look at the time series and you can see what would be the minimum temperature. We see that in general in Pvsyst today the default is use something like minus 20 degrees, or if you're in a hot country you use something like 0 degrees. So and there are some databases available for the minimum design temperature, but we feel that it is far from accurate and reliable. particularly, okay, if you are in Europe or United States, you still have a high density of these temperature measurements. But very often, if you are in the middle of nowhere and the nearest meteo station is 200 kilometers away, then you can have a very inaccurate insight on what is the minimum temperature. We are also working on a database for minimum temperature so that we can make this available to our customers. We already have first versions available, but we have found out that the accuracy is not as desirable in some very remote regions. So we are working on fixing that, and hopefully this will also be a data parameter that will be available in a few months' time.
Perfect. Thank you so much, Harsh. Okay, next question. What is the source of our ground measurement data and the accuracy of these ground measurements, location, and where can we find this information?
So we are not using any ground measured radiation data directly as input to our model. However, we are using ground measurements for validation of our model. So as of now, till date, we have done something like 230 public validation of our model. So you can see the results of all these public validation sites on our website. In addition to that, we have several hundreds more validation points where the results are confidential because the measurement data are provided to us by our customers and it is their private data. Here we are always trying to add more public validation sites. It's not a very easy exercise because before we run each validation, it takes us like 1 or 2 days of work to do a quality assessment of the measured data and exclude data readings that do not pass the quality assessment and then run a comparison. But just in the last couple of months, we've added, let's say, another 10 sites in Latin America, also in Europe, or we are trying to plug gaps in the validation database. So we are aware that in some regions we do not have enough validation points at the moment, and we are working slowly on fixing those things.
Exactly. And in the web, in our documentation, you can also find all this information with where are our validation points and so on. Okay, thank you, Harsh. Then we have another question. When we create an PXX TMY, P50, P90, are the values in the month adjusted so the overall GHI sum over the year is correct, exact value?
So if I understand, this refers to how we
the generation of TMY. Yeah, so the sum of the GHI and other parameters is exactly as the sum.
Yes. Yeah, so maybe, yeah, to just quickly explain how we do. Of course, we know that we use time series, right? And we use the most representative functions. Now, if I just want to sum it, right, beside the fact that we use those two main criteria, as I mentioned earlier, what we do is that if we take example of January, so we calculate all the Januaries. From existing time series, right? And then what we do is that we also calculate the average values from available Januaries to end up with the average January from the time series. And then we choose the January which is the most closer to the average values of January, right? Data. And of course, for the so we use that to make sure that the values that we have are representative. So
yeah, it was explained pretty well. So in case you have more doubts or deep doubts about that, don't hesitate to contact us, and we can just give you an email with all information. So thank you, Mamadou, for your explanation again. Also, how can we check the year-to-year variability and the uncertainty of the TMY and the prospect data?
So it's not, this information is not available with the TMY and prospect. The year-to-year variability information is only available with time series data.
Mm-hmm. Yes, in the report, when you download the data, you can check the variability and the uncertainty upon request we can give to you.
Yeah.
Mm-hmm. Okay. Does prospect permit definition of LID loss for PV modules?
I believe this is pretty much what I explained in the slide where we did the losses correlation. So yeah, prospect pretty much take into consideration the degradation of year zero, right? So that's why you always need to consider that as an initial and at the LID, right? Value.
Mm-hmm. Yeah, so the difference, like year in prospect we simulate year zero, right? And then in PVC it starts from year one. Mm-hmm. Okay. Can we repeat the conclusions just to make sure someone didn't understand exactly the conclusion slides?
Sure, I can go back to the conclusion. Give me a sec. Yes. So to just explain, yeah, what we try to the message we wanted to forward here is that when you do a pre-feasibility where you just do a lot of I would say simulations in order to understand the potential of energy production in a specific site or a specific or sites or to just have an understanding of what's the potential of solar into sites, you can rely into prospect, because in prospect you have the maps and you can also run the simulation, right? And what we tried to explain was that there is literally no point into importing data from prospect into PVCs when you are working on project on due diligence, because due diligence is the phase where you do engineering, more advanced simulations. So it is much better to use time series where you have more data granularity. Sorry, you can have where you have like year-to-year variability and all those aspects. Yeah, so we recommend to use the time series to import into PVCs for project development. And we presented here also some of the other advantages of why we recommend to use the time series. So that's pretty much, if I just sum it quickly, what the message we wanted to forward to you here.
Mm-hmm. Perfect. Thank you so much, Mamadou. I will be not reading like some repeated questions. So again, can you give us an insight about the uncertainty of Solargis data in time series? In which range of values are we moving?
Yes. So for GHI, we are between the ±4 up to ±8, right? In terms of uncertainty, when we refer to, yeah, in terms of uncertainty. So this is compared to the values which are at least presented by other data providers. We do have, I would say that using Solargis data appear to be among the, if not the most accurate in terms of uncertainty provided by GHI data in the market. So I would say we would be between plus minus 5, yeah, or 5.
Mm-hmm. Okay, perfect. Okay, another question. Okay, about the pricing, you can always check in our web or just write an email and we will give you offer. Also, is there any facility to calculate the energy yield for bifacial modules?
Okay, so this is an interesting question. Bifacial simulation possibility, it's a question or a request that, yes, we have been having lately or in the last month. And we are currently, we have been working into developing the possibility to simulate bifacial. So I'm pleased now to inform you here that this, we have done a lot of progress, and I would say we are pretty much into the final lines of releasing this. So we are currently doing a lot of testing, benchmarking, and I think soon we should be able to have the possibility to simulate the bifacial modules.
Mm-hmm. Okay, perfect. Thank you, Mamadou. The temperature of the string sizing should be not the ambient temperature, but the internal cell temperature of the modules. Does Solargis take into account when calculating the string lengths? It's more technical questions.
So I can answer this. So as was explained earlier, we are not doing string sizing right now, but we can provide you data both on ambient temperature, and also we can calculate for you the data on module temperature. So this is a parameter that is already available via our Timeseries API service, where in the request you can define the module type, the tilt angle, and based on these inputs, you can get the module temperature value as well.
Perfect, thank you, Harsh. Okay, also they're asking if we consider the topography, the terrain slope, and so on, so basically the horizon in prospect.
Yeah, we have horizon database that has been created from elevation data at 90-meter resolution, and we put in a lot of effort to creating this data source. So we are using publicly available data sources, but the added value work that Solargis has brought in here is that in the publicly available terrain databases, there are sometimes errors and gaps, and we have patched together the terrain data from 3-4 different data sources, and from that we calculate the horizon data.
Perfect, thank you so much. Okay, so pretty much all the questions are more or less answered. So in case if you want to write last questions, but in case you need more information, please don't hesitate to contact us. You can have our email is contact@solargis.com. So in case you need to ask for some questions, we can help you. We have one last question. The simulation that was done using 27 years of time series data, the final performance ratio was the average performance ratio over the 27 years?
Yes, that's right. So what we have done is that we run 27 simulations, 27 single simulation into Pvsyst, and we did the average values of these 27. However, you probably know that you can also do batch simulations or use the degradation function to simulate one time. But here we wanted to have like more accuracy in terms of the final value, that final yield, energy yield, or performance value that we show. Hence, yes, we did these 27 separate simulations and made the calculate the average value.
Yeah. Okay, I see some more questions coming. Some are more technical, so I suggest that you can write us via email, and just answer for the last ones. Could you please define conceptually difference between TMP50 and TMP90 and the difference in the yield?
Yes. So we already know how we calculate TMIs, right? So this is good. It's 1 year data calculated from time series. Now, of course, we also talk about probabilities of occurrence. So that's why we talk about TMP50 and TMP90. So TMP50 represent a year with average climate conditions and most representative cumulative distribution functions. So that means that we do not talk about the extreme weather, right? And when we talk about TMP90, it's a year with a low or conservative solar resources, meaning the annual GSI, DNI results after, GNI results calculated after at the P90 value. So to understand maybe a little bit more, we then can talk about more, when we do the physical representation of the probability of density, where we have the Gaussian curve, right, against the energy. So we talk about P50 when we have a 50% of occurrence. So meaning that we have a 50% of occurrence in terms of the solar resources or in terms of the energy yield which will be produced. However, when we talk about P90, this is much more conservative. So it's like more drastic, and usually for financial aspect of PV project, this is required by the bank. So there it's much more the occurrence, but the probability of occurrence is much more higher. And the difference between the TMP50 and the TMP90 can, of course, be reduced by using high quality data when we talk, meaning that data with low uncertainty. And that's exactly the case of our data. So that's why you should be using Solargis data for your further simulations.
Yeah, I'd just like to add that the TMP90 file is okay if you want to know the P90 yield on an annual basis. But recently, some customers have written to us and they want to know P90 on a monthly basis, or how on an hour or more granular basis. So in such case, it is not possible to use TMP90 file, but for such analysis, then you should run a simulation with multi-year time series, and from that derive all these statistics.
Perfect. Okay, so basically that should be it. So thank you.
I see
for the presentation.
Some more questions, but I don't know, we can go on, or if I don't think we'll have time to answer all the questions, but we can definitely try to answer them and send it by email to all the participants. Yeah.
Exactly.
Yes. And Martha, I just wanted to add before you wrap up that we will probably, when sending you the materials, reach out to you with some feedback if possible. So we are interested to see how this webinar have helped you, and see if you have also specific topics that you would like us to cover for as a webinar or develop in the future. We will be very happy to have this insight from you. That's all, Martha. You can take it away now.
Yeah. So that's it. So basically, yes, just a conclusion. We will try to answer all your questions and send you via email, and all the documentation that we use in the webinar, like the slides, we will be sending to you too. So thank you, everyone, for joining this webinar, and we hope to see you in our upcoming webinars. So thank you guys also for the presentation.
Thank you, everyone. Bye.
Bye.
Goodbye.